Thanks everybody for joining us today. We're super excited to talk about data quality. So super popular topic, kind of impacts everybody, certainly working with Airflow or just working in the data space. Before I hand it over, just a couple of bits of housekeeping. I mentioned if you can change your chat to send messages to everyone so that everyone can see them. As we go through, definitely ask questions. You can use the Q&A feature in Zoom for that, or you can throw them in the chat. I will be answering anything I can as we go through. And if it's not something I know the answer to, then we will have time at the end for Benji to address any additional Q&A. Last bit of housekeeping, this webinar is being recorded, so you will get a email afterwards. Everybody who registered will with the recording, so no worries if you miss anything or want to rewatch. That will also include links to any public code or examples or anything that Benji goes over. So that will all be available to you afterwards. And with that, I think that's it for housekeeping. So like I said, we're talking about data quality today, particularly one of the newly released providers in the Airflow project, the Common SQL provider, which is super exciting. And we're really lucky here to have Benji Lampel presenting on that. And he wrote the provider. So you're hearing it straight from the source. So you're awesome there. And with that, Benji, I will hand it off to you.
All right, thanks, Kenton. Hey, everyone, I'm Benji. I'm an Airflow engineering advocate here at Astronomer, and I focus on data quality at the company. So today we're going to go through, as Kenton said, this common SQL provider that's brand new. We're going to talk about a little bit about why this provider exists, the new operators released under it, and how it operates with OpenLineage. I'm going to share my screen here, and we're going to just jump right into it. So here, actually, let's not jump ahead too much. And let's take a look at this presentation for a little bit and introduce all this different stuff. So the webinar today is native data quality in Airflow and OpenLineage. For those of you who have done data quality in Airflow before, you may have found it lacking. You may have found it great. While there are tools that integrate with Airflow right now, I found that there wasn't a really strong data quality story. And that's part of why I put this provider together and these two new operators together, was to create a really consistent, easy to use and versatile set of operators to tell a very simple and very powerful data quality story, especially if you haven't done data quality in the past and you're more familiar with Airflow than any particular data quality tool. And that there would be a story that included OpenLineage, which is a new core part of the Astronomer platform. And that allows us to really take a look at not just what our tasks and our DAG are doing, but how that relates to all of the data sets that are being manipulated as well. And we'll see how this becomes a pretty powerful part of the story. So real quick, for those of you unfamiliar with Airflow, it is a data orchestration tool. And if you really have no experience with Airflow at all, I highly recommend one of our Airflow 101 webinars. I believe we have some recorded. We also have a lot of information on our blogs. So I won't get too deep into what Airflow is. Astronomer is the managing layer on top of that. We provide a lot of services in and around Airflow, as well as contributing a lot back to open source like this provider. And now why we want to do data quality with Airflow in particular? Well, we have a few advantages when we do it with Airflow. We get in-pipeline checks. That means we can check at the table level, columns. We can use different staging patterns, and we can bring in other tools to allow our pipelines to make sure that there is data quality at the degree that we want it at. And if something fails, we get immediate alerts. And with Airflow, we can alert in various different ways, including email, Slack, and PagerDuty, or checking directly in our task logs. Finally, data quality with Airflow gives us strong lineage support through OpenLineage, which increases our mean time to resolution and allows us to do some root cause analysis. So the data quality use cases, there are a few out there. Today, we're pretty much going to focus on the static checks and what those static checks are useful for. Excuse me one second. The other major data quality use cases are metrics. So things like row counts, column counts, the number of bytes received, and things like quantiles on different datas. These metrics are more like metadata for our data sets. They aren't necessarily giving us a true or false value back. They're just giving us the information. The static checks are more focused on those true or false values. We're going to give these checks a set of assertions, and these assertions have to come back as true. Otherwise, the task fails. These can include checks on things like typed values, ensuring that columns that contain integers actually contain integers, data ranges. So making sure that, say, we're going to look later in the demo to make sure that we don't divide by 0. So data range could be ensuring that data is greater than 0. And then temporal intervals, things like date checking. Finally, there's anomaly detection, which again, we're not going to go into really at all in this webinar, but these can be machine learning based or statistics based. And essentially what you're trying to do is, for a set of data that's coming in, you have some sort of idea of what that data should look like. And if there's any data points, any new data points that looks sufficiently unlike the data that you had before, you get an alert about it. So let's talk a little bit about what this Common SQL provider actually allows us to do and what these operators look like. So the Common SQL provider, as a new provider, does one thing really well, which allows us to make updates to these operators much more quickly. Currently, all of the SQL operators, including the checks, are part of the core SQL library, which means that they only get updated and released at the pace of Airflow releases, which is kind of at best quarterly right now. Whereas these providers allow us to do releases monthly with the provider releases. So that means quicker updates for things like bug fixes or just additional operators and additional functionality for these existing operators. You'll see here on the left that we have a list of supported databases. And basically anything that uses the DB API hook, you can use with the SQL operators, and we'll see how to do that by passing a con ID later. But essentially the hook in the module is that DB API hook. It got moved over, which means that we have kind of a common framework for all of these operators to work with. The one big exception right now is BigQuery. BigQuery uses job IDs to kind of manage the queries and the jobs. And these SQL check operators don't use that job ID and they don't create one. However, I'm working on a solution for that right now. And ideally Astronomer will provide that through Astronomer providers very soon. So we're working on that release, and we'll have BigQuery support as well in the form of BigQuery column check and BigQuery table check operators. So let's look a little more into what these operators are, what they do, and how to use them. So let's start with the SQL column check operator. This is what I call an on-rails operator because you're not actually writing any SQL to use it. If you'll see here, the column mapping, we have a nested dictionary, and this is actually what you fill out as a kind of spec to run your checks. This column mapping at the top level will take the column names, and you can have multiple, as we'll see in the example. You can have multiple column names. So you could have a set of column checks for every single column in a table in a single operator. And this just helps you cut down on the number of operators that you have running. Within each column check, or within each column, you can have multiple checks per column. So we see here that we're doing a null check and a distinct check. And then within each check, there are a few configurations that you can do as well. We have an equal to 0 here and a tolerance. This equal to 0 is ensuring that we have the actual metric that we're checking with a specific value. So here we want to make sure that we have no nulls. And this tolerance is a decimal. And it essentially says that we can have a percent of essentially like failure values and still allow the check to pass. So if this tolerance was say 0.1 or 10% instead of 0, and our check returned, the query returned say 9 null values, the check would still pass even though this equal to is set to 0 because we have a 10% tolerance. Actually, I don't think that's quite right. If this equal to was 100, the 10% would allow 10 on either side. So we'll see a little more what we can do with this equal to and tolerance in just a second. The last thing I'd like to say about the operator before we move on is this idea of partitioning. That essentially allows you to add a where clause, so you don't have to run all of your data on your entire table every single time. So the available checks with the column check operator are a min, a max, unique check, distinct check, and null check. And if you want to learn a little more about these, there's a bunch of documentation and guides available. And our qualifiers here are greater than or equal to, less than or equal to, and equal to. While this doesn't give us the ability to do every single check under the sun for a column, it does give us a pretty big base with which to perform checking. So the SQL table check operator, we have a little more flexibility than the column checks. And again, it supports static checks the same way that the column checks does. We're not really looking at metrics. We want to see things that have a Boolean result, something that's true or false that we can pass or fail on. And this one also allows partitioning with a parameter, which gets converted into a where clause under the hood. And we'll see that later. We may see that later. And then the other thing to note here is that instead of a column mapping, we have a checks dictionary. And within the checks dictionary, we have custom named checks. So this row count check is something that I wrote in to describe the SQL that's being written as the check statement. And a check statement is the one required and only argument given as a condition under the row count check. So for every custom name check that we have, and we can have multiple, and under the hood, these get union all together. We have one check statement, and then what that statement is gets moved into a case statement in the SQL, and we will see that later and how this ultimately works. Suffice to say, this row count check is ensuring that there is one row in our table. Not the most useful check for one row necessarily, but it serves as a good example. So what is a SQL table check operator useful for? Well, we can check anything that includes aggregate values across the whole table. Say we want to compare the average of one column to the average of another using that AVG function. We can do row count checks like we saw before. We can check the schema of a table to ensure that it's what we would expect. And we can do things like comparisons between multiple columns, both in aggregated and non-aggregated forms. And we'll see an example of this later where we check a sum. So let's look at the demo and dive a little more deeply into how this all actually works in practice. We're going to take a look at the complex snowflake transform DAG, which is a demo DAG that I put together in a demo repository that I run. And basically what this DAG is going to do is it's going to utilize a bunch of different static checks through these new operators. We're going to see multiple layers of data quality checks and talk a little bit about why that's important. We're going to do alerting to Slack on failure using the on failure callback built into Airflow. And we're going to see how this native OpenLineage support actually works. So let's first take a look at what this DAG graph looks like. So when we pop over here, this is our DAG graph for that complex snowflake transform. And we see here, because it's a demo, we create all of our tables, and then we load data into this cost and forest fire tables. We'll do a data quality check on each of these tables as well, doing a set of column and table checks for each one. And we'll look at what those checks actually are in just a minute when we peek at the code. But for now, we'll just take it kind of at face value in these task groups. And we'll talk about why we have these as task groups as well. When these data quality checks pass, we'll load it into a combined table, this forest fire cost table. which has some columns from the forest fire table and some from the cost data table. And we load these into here because we're going to actually do a transform on this table specifically, which is our business logic for this example. So we want to make sure that if we're only loading good data into this forest fire cost table, but even after we do that load, we'll do a couple additional checks for the transform specifically, because this transform, we're going to have the possibility of dividing by 0 or introducing negative values that we don't want. So we're going to ensure with these quality checks that we don't do either of those things. And finally, we just clean up these tables because it's an example. So we'll just delete them all at the end. I want to take a quick look at the code here before we hop over to what this looks like on the lineage side of things. We won't spend too much time looking at the DAG code, I promise. There's just a few kind of important things that we want to take note of. So one really important thing here is our Slack on failure callback. What we have here is a function, because the on failure callback takes a function and it'll execute that when the task fails. And that function can be anything we like. In this case, what we're doing is we're building a Slack message that's then sent to a data engineering channel in this by this Slack webhook operator. And so we pass it our connection, we pass it the Slack message, we give it the channel, and we'll call it failbot. And then what we do is we just returned the execute instance of this, and this failed alert.execute will actually just run the operator in the given context for us. So within this on failure callback, we can do a lot of different things, one of which is actually just executing an operator directly. In the DAG itself, the only thing I really want to point out before we dive into the DAG is this template search path. This template search path actually allows us to write our SQL files in another place. And then when the operator is actually executed, we can pass the name of the SQL file to the operator, and it'll look for that SQL file at this location. Finally, we're going to just look at a couple of our task groups in the data quality section down here. And we see our transform, we see an example of that template here. So in the task group, we see that we give it a group ID and some default args. Being able to pass default args into a task group is actually, for me, one of the greatest features of a task group. This default args can also go at the DAG level. But when we have a mix of different operators, like the snowflake operator and these SQL check operators here, we don't always want to pass all of the same arguments to every single operator. For instance, the snowflake operator will automatically look for a default snowflake connection ID in your Airflow connections, but the SQL column and SQL table check operators won't. So what we can do is we can pass that con ID as that snowflake con ID to each of those operators directly through this default args. And we can also give them both this on failure callback that we don't want to give to the other operators either. So this task group allows us to group operators together in a bunch of different ways. In this case, I want to group them together by the tables they're checking and by the kinds of arguments we want to pass to them. Within the task group itself, we have one column check and one table check operator. And we see here that we pass it the table. The column check operator has a column mapping looking at both the ID and the RH. The RH stands for relative humidity. And while the ID is doing a null check, where we're looking to make sure that the nulls are equal to 0, the relative humidity is looking for a max. And that max value needs to be less than or equal to 100. Because a relative humidity above 100 would imply more water than can fit in the air, which, according to the physics that I know, is impossible. So we want to make sure that we have a relative humidity less than or equal to 100. Otherwise, we know that it's probably just an invalid value. Now, we could also add another one that would be a min and make sure that that min is greater than or equal to 0. Data quality is iterative, and when we find issues like that, these operators make it really easy to add those to make a more robust data quality suite. So all we would have to do to add that is just add one more feature to this dictionary. In our table level checks, we see that we're just doing a row count check like that example before. We call it row count check, and we give it a check statement here. And that check statement, because we're passing it in a few times, I just made it a global variable here at the top. So it's a count star equals 9. So whenever we see that row count check, we know that it's just a count star equals 9. Now, the other two task groups for data quality are very similar. In fact, we pass the same default args to each of the task groups. Here in the column check operator, we see that it's a little more complicated because we look at more columns, but each one is still only taking a single check, although they can take multiple. The table check operator here as well is very straightforward. We're just doing a row count check. And then finally, in this forest fire costs task group, we see that we're checking that the column mapping, this area, the minimum is greater than or equal to 0, because we want to make sure that the area represents some actual geographic place. So we want to make sure that that's going to be greater than or equal to 0. We can't have a negative area for, I assume, similar physics breaking reasons as the relative humidity. And then our table check, we actually see we have two table checks here. And we have a count star equals 10. And we have our total cost check here, which is our land damage costs plus property damage costs equals lost profits cost plus total costs. Now, each of these check statements are actually wrong. And this is just to induce a failure for the example, but we'll see later, for whatever reason, maybe all of these count stars for the table rows were originally hard-coded and an engineer came through and added this row count check and just missed one. And for the sum here, you can always get business logic lost in translation, especially if a business team is writing one set of checks and then handing them over to engineers. There's always a possibility for some sort of miscommunication, or that checks were originally written wrong, or that a simple human error happened on the engineering side. There are a lot of possibilities, but this also goes to speak to a little bit about who's in charge of data quality decisions and who the kind of data experts are for any particular domain, and the importance of communication there between the domain data experts and the people writing the checks. That these mistakes can happen, and we want a tool like these operators that makes it really easy to fix these mistakes. And these mistakes are pretty easy to fix. All we'd have to do here is change this string to be that row count check. And all we'd have to do here is move this with the plus over to the other side of the sign, and our checks would be fixed. And then with Airflow, of course, it's really easy to rerun this DAG. All we'd have to do is go back to our graph or go back to our grid. We can click on this and we can clear it and have it run again. Now, before we dive into the log of what's going on here, let's take a look at what the OpenLineage side of this piece looks like, especially when we have a failure. So we see here in our little sandbox and Datakin. Datakin is part of the OpenLineage suite. It's a paid version. The open source version of Datakin, which is a little different, is called Marquez. And if you want to do stuff, especially some local testing with Lineage, Marquez is a great tool for that. But if you want the full, robust OpenLineage experience, Datakin is the way to go. So when we open this up and we see our issues page here, we see that we have one issue. We see that it's trending up, and we can click over to our job execution issues, and we see, oh, here we go. We immediately get exactly what task failed from Airflow. And when we click into that, it drops us over into our lineage graph here. And if we zoom out, we see that our lineage graph is a little complex. It's a little more complex than our DAG. because it's actually looking at not just the tasks that are running like this one, but the data sets that are involved as well. And we get to see other tasks outside of our DAG that interact with those data sets also, like this column check here, or even better, these check row datas. We can see that this came from simple snowflake, which is a completely different DAG altogether, but it still shows up here as part of the entire pieces of the lineage puzzle. If we zoom in here, we see that we have our forest fire cost column checks and our forest fire cost table checks. We see that these all completed. We see that this failed. And if we want a little more information about what's going on, we can drop over to our inputs and outputs. We see that there's only one data set this relates to. And when we click into that, the lineage graph actually updates to looking at this. And we see when we hover over with our tooltip, we get our Snowflake namespace, the schema and database and table in that namespace, and we get to see the results of our quality checks at a high level. These other orange arrows also light up, and we can see what else touches this data set. So we know immediately that there might be an issue here with the insert query, or there might be an issue with the underlying data because it comes from this forest fires data set as well. And these don't light up because they're kind of in the same box together here. But if this cost data set was also used somewhere else, then we would see arrows there as well. So within this data set, we can click on the quality tab, and we can actually see all the data quality checks that ran. So we see our quality metrics. We have 2 failures here. And when we take a look, we see actually 4 pop up. And this is because this is just a quirk of that I use the same data sets and the same names across multiple demo DAGs. So we see that we have a mix of failing and passing DAGs here. And as time goes on, we see that they're passing on 8/31. And we see that because we had this failure here and the alerts before, we know that there were some failures going on as well. I think this just hasn't updated from when I ran it earlier today. But we can also see the column checks here. And we can see that we have a column check on area and that this is passing just as we expected it to. So that's what this looks like in OpenLineage. And I like this a lot because it gives me a sense of not just what's going on in my DAG, but what's going on across all the different DAGs, and being able to look and see from a very high level what this entire data ecosystem looks like and what other tasks and what other DAGs might be influencing my data. So if we look back over at the DAG graph here, we can actually go into the logs of the check. This is actually the last part of the demo. We can look at the logs of the check here and see what does the operator actually tell us? What information does it give us when something fails? And we see here, we actually get a full statement of the query, and we get a little bit of an idea of how this SQL table check operator works. Like I said before, our count star 10, this was the only SQL that we actually wrote in the operator. It gets nested in this case statement. And this case statement basically says, we're going to return 1 when this is true, and we're going to return 0 when it's false. And we're going to call it the row count check. And then we see here in the above select statement, we're selecting this row count check from the subquery below. We're selecting it as the check name. And then we're selecting the min of the row count checks as the check result. So this query will run on every row in the table or every row in the partition. We would add a where clause below as part of this from if we had the partition. So this select statement is selecting from here. And because we're using this min, if any zeros occur in any of the rows, it'll float that 0 up to this level, and we'll get 0 as check result. And so when we have this top level select statement, we'll get the check name and the check result from these subqueries below. And we'll get that for each of the statements that we pass. So we see this union all here. We have our total cost check. So we'll actually get 2 rows back, and we see here in the results, we have our check names and our check results, and we have our 2 rows back, our row count check and our total cost check. Because these both return zeros, we know that a failure occurred. Finally, down here, we just have a little bit of extra statement saying more or less the same thing, but we get to see again, outside of the SQL statement itself. So we don't have to parse through the whole SQL statement. We can see what did we actually write. Sometimes that's a little easier to help identify, oh, this is on the wrong side of the equation. Whereas if it's all part of one statement up here, sometimes those things can be a little more tricky to look at. And we get to confirm here that the success was false. And that's about it for the demo. So I'm going to stop sharing my screen here and say thanks to everyone and open it to questions.
Awesome. Thanks, Benji. That was a great overview. These are really cool operators. We have lots of questions. So
great.
Great engagement from the audience. I'm going to start working my way through these. So got a couple on just kind of the implementation of both of these operators. The first one is when you're providing a column mapping, could that be taken from another table in your database, or do you have to provide it manually within your DAG script?
You do have to provide the column mapping manually. One of the kind of downfalls of static checks in general is that it is a lot of a manual process. And that's part of why I also mentioned it's an iterative process. I think it's kind of unreasonable to expect somebody to write thousands and thousands of checks by hand in, their first iteration, but you may want to write a few core checks in one sprint, and then, every sprint or so add some other very necessary checks and build your data quality static checks out over time. I know there's also a bit of a market now for different analyzers and tools that are being built by other companies that will do some of that process for you.
Awesome. That's great. How about, are any of the operators variables parameterized?
The only one currently parameterized, I believe, is the where clause. I have to double check that.
Okay. Cool. Not necessarily related to that, but potentially related to that. We had a couple of questions on what if I need to run the same set of checks on multiple tables? So kind of 2 parts to this question, I guess. One is first is what are my options for implementing that? And then the second is what are some considerations if you have tables of kind of varying sizes or need to optimize for resource utilization in some way?
Okay, so for the first part of that question, one thing that I like to do when I'm writing a lot of tests is I'll have a separate Python file in my include somewhere, and I'll just write the dictionaries there. And if you have those dictionaries written, any tables that have the same columns can use them if it's the same checks. So it's not quite templating, but you could just say, import common table checks from your include/common/tablechecks.py file. And you can just write those dictionaries there and have one place to write all of your checks. We actually have someone here at Astronomer who did that for our internal DAGs, and it works great. So it allows us to do that reuse over and over. Again, not quite templating, but it'll get the job done. For the different table sizes and not wanting to run everything over the whole table every time, these operators do support partitions. We didn't really get a good look at that during the demo, but the operators do support a partition clause statement, and that will essentially gets turned into a where clause. So you can do things like partition by date or partition by some other field if dates are not available.
Well, Thanks for that. Again, kind of related. So we have a couple of questions around kind of optimization and what to do if your data size is really large, running these queries. So one is if you have multiple checks defined within an operator, are they executed sequentially or in parallel? And is there any sort of optimization happening there?
So yeah, I didn't show too much under the hood of how this works, but we saw in the SQL table check operator that all those select statements get union all together. So they actually get sent and run as one query. The column checks work a little bit differently. Every column has its own query built. So if you have a column mapping that has 10 columns in it in one dictionary, it'll still send 10 queries to the database, but it'll all be handled by the single operator. So that will be sequential based on the columns. And if you want to make it parallel, then you would use one SQL column check operator per column. And that'll send all of those selects, all those queries for each column individually.
And just to throw out there, if that sounds like it would be more what you're looking for from an optimization standpoint, but you balked a little bit about having a separate operator for each check. If you have a lot of them, that's something where you touched on this a little bit. You can use dynamic task mapping as a feature, and as long as you're on Airflow 2.3 or greater, so that you can essentially just define one operator within your DAG and then map based on the different checks that you're going to run in some other file. So an easy way to implement that if that ends up being better for resource utilization there.
Oh, and I just double checked on the templatable fields. It's just the partition clause. So what ends up becoming that where statement is templatable, but the other ones are not.
Great. And then again, kind of related to efficiency. So are if you do a check like a row count or a schema check or something, is it running that over the entire table, or will it use some of the table's metadata behind the scenes in that query to make that more efficient?
The operators are pretty simple. And if you're doing like a count star or something on the table check, it will just run the count. So those are not optimized right now. And again, these are kind of the first iteration of these operators. And if you'd like to see changes or contribute your own improvements, these are part of the open source Airflow project. So please feel free to open up an issue or create a PR and make those changes.
Yeah. Awesome. And then a couple kind of related to maybe future iterations, but we had a couple just questions confirming what databases or source systems are supported. So specifically around Hive and Athena, which were not on those lists. Gee, I don't know if you want to speak to kind of future efforts there.
If those are, and I'm not sure if they are, if those are DB API based, then they should be accessible now by just passing your current connection via the con ID. I would definitely recommend that you try that out at the very least. If those are not DB API supported databases, then they currently are not available. And if you'd like to see them available, then definitely open an issue in Airflow and go ahead and tag me in it. Or if you want to just make changes yourself, go for it. But a few of the other providers, things like the BigQuery, for example, because of the way these operators are working and work under the hood with that DB API hook, sometimes it's just not compatible to simply add these to the operators, but new operators have to be made that would subclass these SQL check ones and use some sort of other connection scheme under the hood. And that's kind of what the BigQuery table operator is doing.
Awesome. And then let's see, we have a question on somebody who's currently using pgmock to do testing in DAGs. I'm not familiar with that tool, Benji. I don't know if you are. Their question was, how is that different?
I'm not familiar with pgmock. All right.
Okay, well, yeah, we're not sure. Definitely interested in hearing any feedback from anybody who tries both. Yeah, interested in that. Sina, as to the second part of your question, the Common SQL provider package is new. So these are new operators released, gosh, maybe a month or so ago, something like that. Benji?
I think coming up on 2 months now.
Yeah. So there were prior to that some other SQL check operators in the Airflow project. They just weren't, they had much more sort of narrow functionality. So this is a net new. Cool, let's see. Can these quality checks apply to data files as you're loading them?
Not currently, but doing other data sources is something that we're looking at, especially on our Astro SDK side. So we're looking at a Astro SDK data quality solution as well, and that would probably be easier to do things like working with data frames or loaded data directly. So these operators, they're called SQL check operators for a reason. They only really work on SQL databases.
Awesome. This is a good question. Is there a way to store any of the results of that validation to a table or a log file? So obviously the results are stored in the Airflow logs, which you might have access to depending on how your Airflow environment is set up. But Benji, any recommendations there?
Yeah, so these operators return the results as part of kind of what they do. So when the tasks fail, an Airflow exception is raised, and you can see the results in the log, and they are stored there. So if you're storing your logs, is say in S3, then they'll be persisted in S3. If you have XCOMs that are being persisted in a backend store as well, then these will, I believe, they'll get stored as XCOMs because there is a return statement. Kenton, correct me if I'm wrong there.
Yep. Yeah. Anything that's returned from an operator.
So they will be stored. And that was one of the big shortcomings of the previous SQL check operators, was they didn't return anything. So all of that data that you got was just lost every time that you ran those operators and they completed.